one and all. Welcome to the data science program. So far, we were discussing about the statistics, and we have come to the last session of statistics. Initially, we looked at the statistics fundamentals, then we moved on to the inferential statistics, right? That's the current module. And the complete theory part of the inferential statistics, the, uh, the fundamental confidence level, and how to use the confidence level for various applications, right? And what are the various types of tests that we can perform using what is called as hypothesis testing, right? Various types of tests also we have seen so far, right? So uh, we have moved to the last part, right? We have come to the last part of statistical analysis, which is called as a statistical testing. So as you can see here, we have opened a Jupyter, which means we are going to perform the programming aspects, right? We are going to deal with the programming part today, right? So far whatever we were discussing, right, right, in the theory part, right, also we have seen few of the problems, right? And whatever we could study there, we'll try to implement that using the coding, right? Because ultimately, right, as a data scientist, you are going to do the coding most of the time, right? So it is absolutely necessary that whatever concepts we had discussed earlier, uh, we should be in a position to write codes, right? So we should be in a position to write codes so that we can do the same testings, whatever the various types of tests we had performed and we had solved the problems, right, in the previous sessions by using the coding tool. Okay, so this is our fundamental idea. We'll call this session as statistical testing. All right. So moving ahead, what we'll do, we'll quickly look at what are the concepts that we have, right, we have discussed so far, and let us try to quickly write, right, what are the various things that we are going to look, right, today, right? So anyway, fundamentally, it's going to be the programming, right? And in the programming session, right, so we will be concentrating on, so there are two parts for the programming session. The first part will be, right, a general idea. We will only create our data set and we will only try to extract many more features from that. Okay, so the idea, whatever we are going to deal today will be, right, initially, right, the coding part, and in the coding part we will be looking at the basic statistical testing, right? In the sense, this means, right, the hypothesis testing, right? So we have seen many types of hypotheses, out of which the very important one is called as the Z test, right? So we have seen the Z test for say one sample, right? One sample test. Then we also have performed the two sample test, right? So those who want to recall, right, quickly go back and check that notes, what is one test, what is two sample Z test, etc. Right? Then we also have performed what is called as a paired. Okay, this is paired test. Then we have performed the two. Okay, this falls under a different category. I'll write it as a t-test, right? In which we have performed two sample test. So this is what we are going to look fundamentally. So first we'll see how to perform each of these tests for a given data set. We have a, anyway, initially I'll show you how to create a data set which is randomly generated, right? We can use the NumPy functions to do that. right? So we create a data set and we'll try to do the hypothesis testing. Right, that's the first part. So in the second part, we will take a practical, real data set, and we'll be performing. Right, I'll give a question. Right, I'll give some time for you to write the code by yourself, explore, and give an answer. Then we'll discuss the actual answer. So that's how it's going to be. It will be an interactive session. So please be ready for programming part as well. Okay, so open up your maybe if you are working on a Jupyter notebook, keep it ready, keep a new session ready, or if you are working on a collab, that's also fun for us. All right, so basically we are going to discuss about the programming aspects of these things which we were studying since the past few sessions, right? Okay, so that's about today's session, right? So yeah, we'll be doing the programming most of the time for today. All right, okay, right, so let us start. So the first part is that let's discuss about it's again a recalling session. Okay? You try to recall something, right? I have maybe I should go back to the same notepad, okay? Because I want to write something here so that I just want to verify, right, whether you are able to recall these words or not. Okay, the one thing is, right, the whole concept of statistics was being referred to as an inference based. In a sense, you will come to an inference depending upon what you observe, right? So depending upon what we can observe from the given data or the data collected, one type of inference that you, right, you will decide is called as a frequentist. So what do you mean by frequentist? Frequentist is I observe a frequency, right? So 10 out of 50, right? Or you can also check like 100 out of 250, like that. It's a frequency based, right? So many out of this. That, based on the frequencies, you will decide something. So that kind of references or the inferences are called as frequentist inference, right? So that's the one thing, right? You try to remember this, right? These are the various topics we had discussed. Second one is called as the inferences, right? You derive based on what is called as a confidence. Okay, confidence. I'll write the more appropriate word here. We use confidence level to decide a confidence interval between this to this. So the election poll, you said that the number of votes, sorry, number of seats won by a winning ruling party or winning party will be, right, 270 to 330. That's a confidence interval. Okay, so confidence interval. Right. So these are the two different aspects, right? Using which, right, we have performed the statistical analysis, right? So the complete statistical analysis, we use these two approaches, right? So just try to recall. That's why I try to here, right? So what we do, we'll directly move on and we'll start coding. Okay. So fine. So initially, what we do, we'll try to yeah, sure, sure. Just a second. I'll go back. No issues. Okay, one is called as a frequentist inference, and the second one is a confidence interval. Right? These are the two approaches used by us in the past few classes, so that we could perform what is called as a statistical analysis related to the inferential, right, statistics. Okay, fine. Right. So as usual, the Python programming requires you to bring in the various packages required. All right. So let's directly start with that. Right. So I'll bring the all the required packages at once. Okay. So right, those who are doing the programming, right, along with me, right, I'll give some time in the middle so that I'll wait for everyone to come to that level. Okay. So everybody can try doing the code along with me, right? Stat models dot API as say statistic model. I'll call it as SN. Then I'll import the pandas as say PD. Okay, I'll also import numpy as NP. Okay, I'll also bring matplotlib dot as say PLT. Okay, then Ruchi, you are not audible. Can you check your mic? I'll correct. I'll correct. Thank you. Thank you. Okay. Yeah. Then from scipy stats import norm. So you should understand. You should be able to understand because we already have used this several times. It's a normal distribution. Okay. Then I can. Okay. I'll bring say from numpy dot import seed. Then from scipy stats. Okay, so let me see. If at all anything else or extra required, I'll definitely bring it. Okay, at a later stage. Right. So this is what we need. So let's quickly look at the concepts of hypothesis. Sorry, Ruchi, audio is not so clear. There is a lot of noise, background noise. Sorry, you're not audible. Can you put your message on the chat, please? I'll see. Okay, sure. So most of the required what you call tools or the packages we try to import here, right? Whatever is required, we'll try to bring it at a later stage. All right. So first, my idea is to look at directly jump into the concept of hypothesis testing, right? Prior to that, various plots of the distributions, etc. We already have conducted a programming session in which we have done that. Okay. So I'm actually continuing from that particular point. Where, just try to recall where we had stopped. We had tried to right represent okay, I'll come to that. So there's a question like what is a seed library? So seed is something like random number generation requires a pattern, right? So that pattern is hidden inside seed. All right, so that is actually present inside the numpy itself. In the numpy random, I'm trying to create a random numbers. So we have to use a seed so that the same random numbers will be generated. Even whatever numbers are generated in my computer, same random numbers will be generated on your computer. Okay, so that can be controlled by if you use a seed, right? If you don't use a seed, my random numbers will be completely different than your random numbers which are generated on. Okay, so this is what is the seed doing. Okay, so as I told, right, we are trying to start with the hypothesis testing here, right? Try to recall what is a hypothesis testing. Based on the question, you will form a H naught, which is called as a null hypothesis, right? Then you have a alternative hypothesis, HR, right? So based on the given data set, you will try to fit a what you call you'll try to fit a distribution, right? And solve for that distribution. Take an equation and solve, right? Form an equation and solve, right? You get a probability. That is what we call as a p-value, right? If that p-value is lesser than what is called as a significance level, that's the confidence, 1 minus the confidence level which you are intended to give an answer, right? So if at all the value is lesser than or equal to alpha, right, which is the alpha value you define, you will reject the null hypothesis. right? And if the p-value you find for fitting a curve, right, for fitting that distribution and solving, after solving, finding out a probability, if you get a value which is greater than your alpha, you say that you retain that particular hypothesis. That's a null hypothesis. So this is what was the fundamental idea. Okay, so I'll try to do one thing, right? Let me try to paste a part of my document. You'll get a complete document as a PDF format at the end. Okay, so as of now, I'm not going to bring everything over there because too much of content over there. I don't want to discuss each and everything because it's already discussed, right? So just try to understand one very important point, right? That is what I'll try to paste. Okay, so just try to recall that. All right, so this is important, right? I have a alpha, I have a p-value. So p-value you obtain solving an equation, right? And there is a predefined alpha according to your convenience. If you want to go ahead and, right, maintain something like say 95% confidence, your alpha value will be 1 minus that, so you get a 0.05, right? Like that. So if the p-value obtained is less than or equal to alpha, right, reject. Otherwise, right, you keep the null hypothesis. This is what, right, you need to recall. This will be applied even in the programming aspect. It's the same concept, right? Okay, that's one. And the second thing is that we have performed basically two types of tests. One is called as a Z test and another one is called as a T test, right? I want you to recall both. All right. So let us try to, I'll try to bring a comparison here, right? So the same comparison which we had used in the theory part as well. Okay. So I don't remember whether I brought a comparison in the slides or not. Okay. But even if you don't have, don't worry, you will get that in the study material of this week, whichever you're going to get as a PDF format. Okay. So okay, let's see, right? So this is what I mean when I said that I'm comparing the Z test with the T test. So, right, what do you mean by the Z test? Z test implies, right, a hypothesis test which ascertains if its means of two data sets are different or not, right? So two data sets are there, their means are different or not, you can try to find out by using a Z test. Try to recall the theory as well as the equations we wrote, right, in the previous classes. Then there is a very close test to T, which is Z test, which is called as a T test, right? So if you try to apply a T test for that, right, how the means of two different data sets differ from one another. So I have a mean mu1 for one particular class, right, or one particular population. I have another mean mu2, mu1 minus mu2. That difference is what you are going to consider in case of a T-test. Okay, so this is the fundamental idea. So what distribution you fit for a Z-test, it is normal. For a T-test, it is student T distribution, right? Difference I'll come to know at a later stage, right? What is the variance of the whole population? It is known in a Z-test, it is not known in a T-test. Sample size, if it is very small, go for a T-test, like crashing a car. At the same time, Z-test will give you a large, you should process a large data set or large sample size if you want to go with the Z-test. Something like, right, you want to decide about who is going to win, right? You know that if you want to go with a 95% confidence level, you should ask at least 16,000 people, right? That's what the calculation we had. Okay, so try to recall everything, right, that is related to this. Right. So anyway, I'm trying to touch and brush up everything so that you don't forget and you don't have to go back and recall each and everything when I do the programming. Okay. Right. So then let's move to the first type of test that we want to do. It is the one sample, right? One set of sample you have, and I'm trying to perform a Z test. Yes. Yes, Manish. Sure. Okay. All right. Now, the first thing that we are going to do, the first experiment we are going to conduct now is based on what is called as, say this is one sample Z test. I'm going to perform this for finding out the mean. Let us see. I want to estimate a mean of something, right? So if you remember, we had the two fundamental categories of problems. First one is to estimate something called as the fraction, right? And the second one was for mean, right? So now I'm going to start with the mean part of that. So what is the equation that you are going to use? Anybody remembers the Z statistic for calculation of mean, not the calculation of ratio, right? Not fraction, it is a mean. Okay, just try to uh, okay, let me do one thing. Let me make this itself as a text column so that I can paste. Okay, all right. Right, so just look at this equation and understand whether you are able to recall something. Okay, so this is the equation which I want you to recall, right? So have you seen this equation? X bar minus mean divided by sigma by root n, right? So we know that when I know the whole population mean and the variance, I can make sure that if I make a sample, right? I make a small sample. Sample is going to have a mean as mu, variance as sigma by root n. So because of that, from where we took that? We took that from the central limit theorem, right? So from there we discussed something and we came till this equation, correct? So what are the meanings I have written? Just try to recall. X bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the sample size, right? Using that we will be able to perform what is like this. Okay, fine. Now okay, let's make a I'm starting the programming now itself. Okay, let's not wait further. So let us say that uh, okay, we let's consider our country, and we want to create uh, a data set which consists of the dummy ages, right, of the population. We have a population, and I want to create a dummy data set which contains the age of. Okay, and I want to test whether the average age of voters in, say, North India differs from the entire population. So you see, I'm testing something, right? So I'll try to write a point here. Okay, so that we don't miss uh, what we are intended to do. Okay, so this is to test whether the average age of voters in North India differs from differs from the entire population of the country, right? So are you able to relate this to the hypothesis testing? This is a hypothesis testing, but what we are looking at, we are looking at the average, right? Average age of voting, whoever is a voter, right? Average age differs from the average of the complete country or not, is what we are trying to test. Okay, so this is what we want to do. This is my question, right? So anyway, you are free to try by yourself, right? Anyway, the comparison part you may not be aware of, but generation of the random numbers, etc., anyway you are already familiar with, because we have generated the random numbers earlier. Okay, right. So let me try to do let me try to create a that data set at random. Okay, so this is how I will try to do, right? So say My mistake. Population ages one. I'll try to create two different things, then I try to club. Okay, now you see, whenever I try to generate the random numbers, I'm supposed to use a seed if the same thing is being repeated at several locations, like I'm doing here. So few of you are also trying to write the same code. If I whatever random numbers generated on my side should be generated even on your side, we will use what is called as np.random. So this is np dot random dot p, right? Whatever number I put here inside this bracket, if you also put the same number, same random numbers will be generated. Okay, so maybe I'll put, say, some number you put 6, 8, 10, right? Whatever I put, if you also put the same thing, same numbers will be generated. Okay, if we either if we don't use this at all, or if you use a different number in the bracket, somebody might use 100, somebody might use 200. So any number, according to a number, there is a pattern, there is a algorithm which generates a random number internally. Okay, so I use 6. If you also use 6, yes, you will get the same numbers generated in this case. So you see, population ages 1, right, is equal to stats dot norm dot RVS for random numbers, random variables, right? I'm generating. So if you remember, we need to pass three things here. One is a scale and one is a location. Scale means what? It's the width of your normal ones, right? Right, standard deviation. And the location says where is it, right? On my axis, where is the mean part? So scale is equal to, I'll use maybe 18, right? Right, and location I will specify that as, say, 45. And also I'll say that what's the size, right? Let me assume RVS is a function to generate random numbers. Okay, yeah. So then population ages 1. I create two different ages and I club. Let me assume that this is the population of the whole country. Okay, 15,000,000 may not be suitable for this thing, but may not be a practical value, but should work. Okay, so then population ages 2 is equal to, once again, stats dot norm dot RVS. I should specify the same thing. Scale equal to, say, 18. Location equal to, I use a different number, say mean 20. Okay, standard deviation 18. And size is assumed to be 1, 2, 3, 4, 5, 6. Okay, right? So this is what happened. Now population ages is equal to, I'll concatenate np dot concatenate. Both of them I'll try to concatenate. That's all. Okay, so for concatenation I should use another bracket. So this is population ages 1, comma, population ages 2. All right, so I created this data. I'll assume that this is the data set of the whole country. Right, so that's the first part. Now I have to create another data set, right, that corresponds to a part of the country which I'm interested. Say North India is my question says, right? So I'll say that this is the North India age. Okay. Again, what I do, I can create a direct big data, right? So in the sense, only one line I can create. But what I do, I create two of them and I concatenate. That brings more variety and more, what you call, spread of the data points. Okay, that's why I'm trying to do this. Right. So you see here, North India age 1 is equal to, I'm doing the same thing. Sorry. Stats dot norm dot RVS, scale equal to 18, right? Location equal to say 40. And now you see this is a sample, right? From the North India, I'm taking a sample, means sample cannot be 10,000. I will not do that. So you know that it will be a smaller number. So let us say size equal to maybe just 30. Let's see whether this works. Okay. So that's the North India age 1. Then North India age 2. Once again, that is stats dot norm dot RVS, right? Scale equal to 18. All right. Location equal to 20. Okay. And I'll go for a different size. So I sample it. I go to a different location in North India and I will sample maybe 25. So you see, right? So this is what we had studied. Instead of making a single location and making the estimate, right? You collect the samples at different locations. There we assume that I'm doing that for large number of times. But again, here I will show how to do it for a lesser one. Okay. So then I'll concatenate them. Okay. So right, this is equal to, this is np dot concatenate. I'll club both of them. Okay. That is North India age 1, comma, North India age 2. Okay, so let's quickly run that. Yes, that also runs very fine. Now, I'll I wanted to test something. So first, let me visualize what is the average age of, right, whatever data set we have created for North India and the whole country, right? So let's check that now, right? So I'll print, right, average age of, right, India. All right. Okay. I'll just give a column. Then, right, what I try to do, I'll try to, right, find the mean of that. So, how to find the mean? This is population ages dot mean, right? So that will print out this value. I also print, right, another thing. So I'll try to print out like this. Okay, so that is average age of, right, India. So this is North India ages dot mean. All right, I hope you're fine with this. So now you see. So average actual value of the whole country's population is 34.97. Let's see. And when we try to sample, right, take few samples from a part of the country, and we want to make an estimate of that, whether the average which I get for a small sample, that sample, can I make a inference saying that the average age of the North Indian people is same as the whole country? This is what is I want to perform. Okay, so let's do the testing value directly. It's easy to do the testing, right? So you don't have to do a lot of code, because mathematical calculation, when we did, we understood that yes, we have to do a lot of calculation, right? So equations, maybe you have to convert the given data into a tabular format for some of the cases, and also you may have to, right, perform uh, substitute in the equation, right, and calculate. Sometimes that's the case, etc. Many things we have done, right? You know how complex it is to do the calculation in a manual fashion, manualized calculation. So what we'll do, right, I'll directly go for the Z test for this. Okay, so Z test, right, I will call it as one sample Z test is equal to, so you see we have uh, yeah, stat models dot API. Initially we brought it, right, so as SN. So that's what I'm using now, because it's built in, I don't have to do anything, right? So it is SN dot stats dot, right, you tell which test you want to do. It's a Z test, right? So Z test, right? I have to pass few of the variables here. Okay, so okay, before that let me show you what this is going to perform, right? So what I do, I'll connect this. So I'll show you. So you may know that how to check what function is going to do, how that function can be used, right? So I'll show you something. Sn dot stats dot, and I'll put a question mark and I'll try to run that. Okay, so you see that the complete details will be shown, right? So you will have to pass, right, these. Okay, so sm dot stats dot z test, I'm performing a z test. I'm going to pass, right, my data, right? I'm going to pass. Which data going to pass, I'll show you later. There is another parameter which is x2, right? So if you see, if you use this particular method of checking, right, you will get the complete details. What are the variables, what values I can give, right? Again, most of the times you will get an example at the end. So again, it's most of the time, not always. So you see in this case, they have not given an example. Otherwise, right, some of the cases you will see at the end how that implementation happens. They will give one example. So this is a built-in a Jupyter notebooks characteristic. Okay, so these are what various parameters you can pass. First thing, yes, I'll repeat. So I'll close this. You see, any function you want to check, right? So write that function as it is. Don't write a bracket after that. Simply put a question. Okay, so if you want to check np.mean, right, simply np mean, then a question will give you the details about that. Right? That's what is my mean, right? So any function that you are using, right? Somebody asked what is RVS. I don't know what is RVS, right? So just write stats.norm.rvs question mark, then run that particular cell. You will get a help about that. Okay, complete help. So what are the options available? How do you use it? Right? What are the parameters you pass? Everything you will come to know. Very handy, right? I use this occasionally, right? Whenever I know the function, but what are the various parameters I am supposed to pass, I don't know, means I'm using it. Okay, so very helpful. I suggest you to use this. Okay, so you see, I'll run this again. So I get this. Right now you see, what is this? X1 is a array, right? That's a data. X2 is also array, second of the two independent sample. If you are using two samples, go for this. But right now I'm not using X2 because I'm using a single what you call one sample, right? So right, everything you have here, right? So everything that you want you can pass. There is a value here, right? It is actually, right, what you want to value actually corresponds to uh, it's a floating value normally. In one sample case, it's a mean. In the sense, whatever x1 I am passing, it should be the mean of that. So you understand, this is what I am supposed to pass, right? So then alternative, we have alternative cases here. So what are the alternative hypothesis? That is your H alpha, right? What you say? So you see the, if you try to remember the theory concept which we have studied, right? So my calculation of the p value, the probability depends upon your H alpha, right? The alternative here, you see alternative hypothesis is denoted as H1. So if at all your intention is to find mean is not equal, then it is a two-sided test. if it is larger than a value, I am supposed to go for larger side, the bigger side. I have a curve here, I want to look at the right side of that. That's a towards positive infinity. And if my h1 says that my difference is smaller value, right, then I'm going for small. So what I'll try to do here, I'll try to make sure that the difference in means is smaller. So I'm going to use this smaller in my code. You can change this as your requirement, but I'm just saying that what I want to do, I have an option to specify in this itself. Which test you want to do, right-handed test, left-handed test, two-sided test, which you want to do, you have to understand that, you have to think about that, then you decide what you are supposed to pass. So these are the must use parameters. I have to pass them. Others, you see, there are many other things may be available that are optional. As of now, it is not related to my problem, so I'm not going to look at that. But you know how to use it, how to find out what are the various parameters you can pass by just using this. Okay, fine. So now I go back. So this is what I don't want. I will come inside this. I know what are the parameters I'm supposed to pass. So first one says it is x1, right? Which means what is your data, right? What is my data? That is the North Indian ages is what I'm trying to test. So North Indian ages is what I want, right? X2, do you have, are you comparing two different populations? No. So say X2 is equal to none. This is what mentioned in the help. So everything I'm doing from the help only. I'm not changing it. Okay. So after that, I know that from my help, I also have understood that. Okay, I'll go to a new line so that it looks neat as well. Okay. So the next parameter that I want to pass is value. So you know that already we have seen this value is nothing but the mean value of your x1. Whenever you are using one sample, you have to pass that. So that is nothing but it's a mean value, I think. Okay, so the we will pass the mean value corresponding to that. Correct. Let me just check once again. Okay, so I'll check that just to make sure that I'm not making a mistake. Okay, I'll question mark. So you get this. So in case of a one sample, the value of the mean of x1 under the null hypothesis, right? Whatever is a null hypothesis, according to that, you pass. Now, what is my null hypothesis? My null hypothesis, there is no difference. There is no difference between the mean ages of, right? Mean ages of North India and the whole country. So which means which one you should pass? You should pass the whole country's average here. Okay, just understand. That's why, just to make things clear, I opened this again. It says under the null hypothesis, whichever is the mean that you are supposed to calculate, that value you pass here. So that means this is the age of the complete country, right? So I'll pass, right? So that is the population ages. It's the total age now. I don't want that. Dot mean is what I'll pass. Okay, so that takes this, and I think there is another one because I'm performing a left-sided test now. So as you know, so for a left-sided test, I have to pass another one, that is another parameter alternative. I'll pass it as smaller. Okay, why smaller? Because my alternative hypothesis says that no, it is smaller. Correct? Because that's what I observe here, right? No, average age of North India is smaller. So my alternative hypothesis is that. So try to recall everything we discussed in the theory, right? We are simply implementing that, right? Whatever we had discussed earlier, we are simply implementing that. Okay, right. This is what happens, and I create the one sample test now. So once I have this, I can look at my results. Okay, how to look at the result? The result is present in two parts, right? One is the z value and one is the p value. correct? So Z and P value, right? Both I can look at here, right? So let me try it. Print, right? The test, yeah, H alpha. Alternative is H alpha. Okay, smaller. Yes, yes. That's why it is smaller. Okay, that's why alternative equal to smaller, right? Yes. What's the name? Okay, one sample Z test in which the first position, right? So it has, right, it has multiple indices you can access. The first index, if you access, right, that give you the test statistics, which is a Z score. Okay, okay, I'll make sure that you understand that as well. So what I do, I'll try to write test statistics in bracket. I'll write Z scores. Okay, so that when this runs, you will understand. Okay, then print, right? I want to print the p-value, probability, okay, corresponding to this set. Okay, so anyway, I know that it's a normal distributed. I will calculate what is the probability that Z lies lesser than this minus 2.28. You know how to calculate. Anyway, we know that there is a standard normal table, right? We'll convert that into this. Everything is done. Let's see. I'm directly calculating that p-value. Okay, so that p-value, right? I can simply fit one sample Z test. It will be located in the next position. Okay, so see that that is 0.011. Okay, now, right, I want you to answer, right? So my question is that uh, the Z value is minus 2.28 corresponds to, right, a p value of 0.011. So if my uh, alpha value is 0.05, okay, so let me write a point here. Assuming alpha equal to 0.05, right? Why? 95% confidence is what I want, right? I want to say that my results, whatever I am going to make a comment now, whatever inference I want to draw from here, right? I want to make that with 95% respect. So now you tell me, right? Assuming alpha equal to 0.05 and the p value, right? P value is equal to, let me make an assumption, close to 0.011. That's my case. Now, right? What's your conclusion? P value and alpha value, if you compare, right? What is your conclusion about my question? My question said that, okay, whether there is a significant difference among the average ages of North Indian and the whole Indian population. So if that is my question, right? Is there any significant difference? That's my question, right? Yeah, we are open for answers. Yes, please give overall answers as well. Otherwise, if you want to give answer in the chat, yes, please go ahead. So the question is, compare alpha and the p-value I have written here, and you should answer whether there is a significant difference among the average ages of North India and the whole Indian population. Okay, so you just have to use one comparison. That's all, right? Just make that comparison and try to give me an answer. Right? That means what I'm asking, I'm just asking you to look at this P and alpha, right? Just look at this table and give me an answer. Okay, I'll also write another thing here, right? That is, what are the various H naught and H alpha we define? H naught equal to H alpha equal to, right? H naught says that no, no significant difference, right? So there is there is significant difference between the North Indian age and the age of the whole country, right? It's less than, greater than, anyway we assumed already, right? You know that my H alpha says that the North Indian age, right, is average North Indian age is lesser than the average age of the whole country. This is what is the second case, H alpha, which is there is a difference. So H naught says it is there, no, there is no difference. They are same. Right? Only because you made a lesser number of samples in North India, it said that okay, you got a lesser value. Make it bigger, you will get a larger. This is what is the complete big picture. And we already got the values. P value is this much, and we took the alpha value as 0.05. Just compare these two and give me an answer. Right? So very simple question. Yeah, please make your attempt. Either type your answer or give me an answer. Compare the P and alpha. Right. So you should, in this case, you have to compare P and alpha. If P is equal to or less than alpha, you reject, right? So P is less than alpha. Alpha is 0.05, P is 0.01. So, right? So this is your result, right? So since, right, the P value is less than alpha, right? What do? Right? You simply reject H naught. That's all. Reject H naught means it says there is no significant difference, both are same. No, it is not that. There is difference. What is that difference? According to your assumption, you assume that the North Indian population's average age is less than the whole India, complete Indian, everybody. When you consider the whole population, the whatever average age you get, it is right lesser than that, right? So that means yes. So this is the answer. So you come to an inference based on what you observe. Okay, so this complete test what we have done so far, right? Anyway, so this normally the cell number 2, 3 are already available because you will have a data set. Right now I don't have a data set, so I had to create. Only thing is that just you need to use this, right? Now you know how to use this, right? For a single sample Z test. Very simple. Just remember this, right? Apply this to anywhere you want, you will get the answer. Okay. You just have to remember this cell number 8, right? Important. And you also have to remember this one table, the criteria for the Z test. Okay. Any doubt? Any doubt we have so far? Yeah, we are open for discussion. Okay. Fine. So we'll move ahead and we'll do something called as write. So let me write it. So I'm going to perform the two sample Z test for me. Right. Two samples. I want to compare the mean values of two different samples. Okay. So far I just had this is a different case, right? So try to recall the various types of problems we solved when we discussed the theory. One was there is a population and there is a sample, right? I'm comparing between the whole population and the sample. This is what we did now. Okay. Okay, so try to recall the basics, right? The H naught is called as the null hypothesis. Null hypothesis is nothing but you will always make a statement that there is no difference. Both are same. What is same now? Both ages. Age of North Indian population, average age of the North Indian population is the same as the average of the complete Indian population. So no difference means no significant difference of ages. I am supposed to write a long sentence. I skipped that. Okay, So that's what is meant by no significant difference. Right. So the question is that in the question part, I had asked a question saying that, okay, there is a country population and I sample few of them in the North India, I get a North Indian population. So using them, I'm supposed to make a decision saying that, is there any difference between the North Indian average and the whole country? That was my question. So I have to make two statements. One is called as a null hypothesis, where I say that there is no difference, right? Because I sampled very less, 30, 40 people in the North India. Right? That's what is H naught. H alpha is an alternative hypothesis, which says that, no, from my observation, what do you mean by from my observation? This one. I calculated the average, right? You see the North Indian average is 34 and the average of complete India, the whole population is 34 average and only North India is 28. So what I observe that North India has a lesser population average compared to the whole India. That's why, right, I use the smaller, right, in the alternative. That means there is a significant difference. Significant difference means it is lesser than the whole average. Okay, I hope that is clear. Depends on you. You can decide. Like 95% confidence is what is very standard, as I mentioned in my theory class. So I have used that. You are free to change. Okay. So go back and check what are the alpha values available on the table. You can select any one of them. Okay. No, no, no. This is not. You don't run this. This is not a running part. Okay. This is a text table. Oh, you see, there is no cell here, right? See, whatever you run, there is in bracket something there. But this is not running. You see, I click, it just goes to the next slide. Okay, because it's not going to run. All right. So this is not a code. I mean, this whole thing is not a code. You cannot run. I think you see here, this is selected as marked. So you see when I move to up, this is a code. Okay, so when you click this, make that as a markdown so that it takes it as a text, not a code. Okay, right. All right. So this is also a markdown, you see, but as I move here, this becomes a code, right? I'm writing a code here, but this two sample z test is not a code, it is a text, right? So machine will not run that. Okay, so doubts clear? All right, let's move ahead. Now, so I want you to recall one particular equation, that's all, right? So mathematically, if you are doing the calculation, this is what we are supposed to do. Anyway, I'm not going to do that, but I just want you to remember something, okay? Only for that reason, I'm trying to, right? Somewhere in my slides, right, you have seen this equation. Okay, so that's actually corresponding to the difference between the two different population means, right? So now I'll try to make another test. Okay, so my question is this now. Okay, so this is to test whether the average age of voters in North India differs from the average age of voters in, see, I'll change this. Now you see, I bring the South India into picture. Okay, now you see two samples. I know the whole country has a particular value. That's fine. I sampled few in the north, I got something and I did a single one sample test. Now you see, I have two sample tests. I move around North India, I collected already some data samples. Now what I do, I come to South India, I move here and there and I collect, right, few samples. Now my test is that whether there is a difference between the average ages of South India versus North India, not the whole country. I'm not comparing. Whole country is the complete population. I'm not doing that. Okay, so if this is the case between two different samples, if you have a difference or not, if you want to decide, you have to go for a two sample mean comparison test by using the Z test. Okay, so this is the question, right? So let's try to do this. Okay, so how the age, North India age. Okay, South India age 1 is equal to, I have to create this. Okay, so this is stats dot norm RVS. I'll go to a different scale, different size. Okay, so scale equal to 15, location is equal to 33, size equal to say 30. Okay, then South India age 2 is equal to stats dot norm dot RVS, scale is equal to 15, location is equal to 20, and size equal to maybe 25. I think I use the same one already. Then I'll create the ages all together. That is np dot concatenate South age 1, South age 2. Then I'll try to print here itself. Okay, print uh, average age of South India. Simply print out the South ages dot mean. Okay, so we got these values. All right, now you see, right? I'm trying to perform the uh, two sample Z test, for which I have to pass even the second variable, right? The x2 which was there, which I'm supposed to pass. That's the first thing. Okay, and let me open that up once again just to show you what I mean. Sm dot stats dot Z test. Let's open that. So test for mean based on this one or two samples. So you should remember that I can do both of them using the same function, right? In case of a two samples, the samples are assumed to be independent. Okay, that's obvious, right? I have taken, so I have not taken a sample based on previously existing sample. I don't have any bias, etc. So it's independent. Okay, so x1 is there, right? That's fine. X2 is also should be there now. So value means, right? It's a floating value. I understand that, right? So one, it means it is null hypothesis. In case of a two sample, it should be the difference between x1 and x2 according to the null hypothesis. Now I have a question to you, right? Understand this line which I highlighted and tell me what value you will put in when I call the function. Okay, just see this. It says that the difference between the means of your two population. What is that? What are the two population? One is North India, one is South Indian. North Indian mean average, mean age, and the South Indian mean age. Take a difference according to your null hypothesis. Now you know what is a null hypothesis, right? According to that, what should be the difference that you enter as a value? So yes, we are open for answering question answer session, right? Please put your answers in the chat box, right? What should be the value? Value equal to something. it says it has to be a float value, and it's a value for a two sample case, because I'm doing the two sample case, right? This is what is expected. So I want you to think about, right, what should be the value, right? So just think about that, right? Because it's a difference. What is your null hypothesis? Can anybody tell me what is a null hypothesis in this case? Both are same in the sense there is no difference between the average age of North India and the average age of the South India. If that is the case, what should be the difference? Zero, right? So is zero a float value? Because it says that the value which you are going to enter should be a float value. So my question is that, so is zero, because answer we discussed now, it has to be zero. Is zero a float value? Yes or no? It is, right? Not same. Always you see, unless and until there is a very specific case like the calculation of the average cost of car repair, right? Where I have just 5 to 6 samples, right? Only under such case we'll make the reverse, right? It is not equal. It is costly. It is very cheap. Like that we discuss only in that case when the samples are very less. But samples are large means you have to go for the equal case always, right? Recall everything we discussed in the theory part, right? So, right? Okay. So always the most fundamental case is that I always assume H naught is something that everything is equal, everything is same, everything is like that only I'll assume. Okay. So here also it can be one sample, two samples, or any case, any type of test you are performing, right? Always remember that you will make sure that H naught says that they are same. Okay. If they are not same, then prove it, right? So I have to prove it. I have to do some calculation, and then only I'll say that no, whatever I assumed is not true. I have to go to the alternative HR. Okay, so that's how it is. So now I'm dealing with the two populations, right? I have to make sure that X naught is saying that they both are same. So both are same means their difference should be zero. That will be the value, right? So value should be like that. Okay, then go to the alternative. Alternative is a string, right? Right. If it is one, what we know, we already know. But if it is, right, if at all I am comparing the means, difference in the means are equal, right? If at all you are trying to do that, difference of means is what I am interested in, right? Then I have to use the two-sided, right? I'm not saying that H1 is bigger, H2 bigger. No, I'm not doing that. I'm just saying that whether they are same or not means it can be more than, it can be less than. So both should be means what? It is a two-sided test. Okay, so I those who are feeling this concept difficult, I highly recommend you to go back to the slides of the statistics and try to revise. Okay, then come back, you will understand. Okay, right. So I understood something. This is what I am supposed to put. These are the values which are supposed to be put up over here, right? So what I do, I'll start my test. So to sample z test is equal to, once again, this is same function, sn dot stats dot z test. Now you see I need to pass x1 first. So one of them you pass. Okay, that is, it's a North Indian ages is what I pass. I also have to pass the x2 is equal to is a South Indian ages. I have to pass the value, right? What value I'm supposed to pass? I know that it no difference according to the H naught. Whatever is the difference, you pass. So no difference means difference should be zero, right? So according to that, I write zero here, and I have to write alternative, that should be equal to, right? I'm saying that either they are equal or not equal. Not equal means it can have higher or lower value. Anything may be there. So that means it has to be, right, two-sided. Two-sided. Okay. Let's run this. Yeah. So this runs, right? So now I have to get the test statistics as well as the p-value. Okay. Mistake. Print. I just write the Z score. Sure. Go ahead, Mona. Hmm. That's because I think the seed, right? Seed is different because the numbers generating are different. You may get different one, okay? Because it's a random number generating, right? See here, these are completely random numbers. Now, if I run again, I may get a different answer. Okay, that's obvious, expected. Yes. No, if you remember the normal distribution which we discussed earlier, right? So there, this is given in very detail, but I'll brief out. So this scale talks about the standard deviation from the center, how much deviation you have for the points you are creating. Okay, and the location talks about where is the mean. I have a sorry, normal curve. Where is the location? Mean can be anywhere, right? So the mean is LOC. Okay, size is how many samples? 30 samples, 25 samples, 1,000 samples, and okay, right. So, uh, it's randomly I'm choosing, right? I'm saying that the standard deviation I want is 50. The average age I'm assuming 33. So mean is 33. Okay. So somewhat related you should assume, because I'm dealing with the age. I cannot write 100 because no country can have 100 average, right? Okay. So with respect to your data which you want to generate, you can assume things. All right. Okay. So I'm trying to print the Z score here. Right? So Z score is Z test of 0. The 0th position will have this print the p value. It's again two samples are test in the index 1 position, right? Both of them let's print out. So Z square is minus 0.63. So what you calculate, right? What is the chance of getting this particular Z score less than this Z score and more than the plus 0.63? You get a chance that the probability is 0.52. Okay. Yes. Yes, Gaurav. Value equal to 0 now. Correct. Okay, I'll go back, right? So you should remember that this value should be put up in case of a two-sided test, right? You will put what should be the ideal age difference between these two. What is the ideal age difference? They have to be same, right? They have to be same means no difference. So 0. Okay? Yes. Hmm. That's how it is giving. It is giving in that way. Okay, the function is written, this whole function, right? sm.stat.ztest. It is written in such a way that it gives first position z score, second position p score. Okay. Yes. Z. Yes, yes, yes. Okay. It's always like that. It's a built-in function. All right. So, sure. Yes, sure, sure, sure. Okay. Now I am asking the same question again. What is your conclusion? Right. So, just check the name whether it is written here and the earlier, right? So, and this one, both are same. What is the error? Can you read the error? The last line, very last line of the error. Can you read that? Very last. There will be the actual error mentioned. Okay. So just check this. Check this. Alternative equal to whatever you have written inside that, right? Is it the same as what I have written or something different? Maybe the capital small letter or dash missing something maybe there. Okay. Just check that. Okay. That will solve. Yeah. Anything? Any other doubts? Meanwhile, I still have the question asked, right? Nobody has answered yet. What's your conclusion? Right? Is my question. Not audible, Ruchi. There is a lot of noise. We cannot hear you. Anyway, let's keep the same alpha. Alpha is always 0.05. Okay, unless and until I change it, always 0.05. Right? Just look at this. The p value less than alpha you reject. P value greater than alpha you keep it. Okay. So now you compare this, right? I'll write the same thing again. I'll just copy this so that where is that? Where is that? Yeah, this one. I'll try to keep it. Okay. Let me let me write here. Right. So alpha is equal to this. P value comes to be 0.52. Okay. Now you make a comparison. H naught says no significant difference, right? Alpha says that there is difference. Okay. Now you tell me what happened, right? Is the alpha is right? Sorry, the p value is less than alpha here? No, right? The p value is greater than alpha. Means what? Look at the table and give me the answer. Yes. Yeah, we have an answer from Ruchi saying that keep the null. Is it right? Just check. Look at the question. Yeah, this is one. P value greater than alpha, right? So retain the null hypothesis. Keep the null, right? So that means there is no significant difference between the average age of South India and the average age of North India. Okay, right? So keep the null. Okay, I'll write the H naught because I have used the term. Okay. Okay, we are open for questions. Yes, any question you have. Anything, any doubt? No doubt? Okay, so hope you are understanding, right, how to implement, right? So the theory part is pretty much straightforward. You should be able to recall that and you should be able to implement that over here. Okay, right. Now, Yeah. Yes. This one. Okay. Okay. All right. All right. That's fine. Okay. Fine. Now, let's do something. Let's go for the next type of test. And this test is called as, right? I'll just write the name. We'll create a data and I will leave you for doing that, right? That's a small type of assignment which you can perform during the break, and even I give 10 minutes extra after the break. Okay, so take that whole time and perform a test and give me an answer. Okay, so we'll create the data. Meanwhile, we have a question. Uh, okay, okay, all right. Then, okay, so we have a question from Deepak. Query is, how can I, what is it? Company avoid type 1 error and type 2 error. Okay, okay. So we will be coming to that part. Okay, as of now, our intention is not to, not about discussing about type 1, type 2 error. Errors will come once again. We'll revisit that. Okay, then I'll answer that question. Okay, right. Fine. So there's a lot of things to study in machine learning. We have not yet started the machine learning. This is still the basics. In the ML, we'll be discussing everything in very much detail. Okay, so I'll answer that. Kindly hold on to it. Okay, so I'm framing a question now. Okay, and what my intention now is to perform what is called as paired Z test. Okay, this is what is my intention. Okay, so let us say I'll try to create a data set. Right? Uh, I have a group of patients, and the weight of the group of patients, I want to say what you call. I want to measure the weight of a group of patients, right? Before the treatment and after the treatment, right? This is my idea, right? I measure the weights of patients before. It can be even an exercise, okay, or before a treatment and after the treatment, right? So before and after, I'll try to measure, right? So what I'm supposed to do here is that I have to decide whether that exercise resulted in, is it useful or not. That's what I want to perform. So that kind of experiment is what is called as a paired test, right? Recall, I think I had given some other example, and we had solved a different question, okay, while discussing the theory part. Anyway, this is pretty much similar to that. Okay, so let's try to do something here, and let's try to create the data set. Okay, so we'll create a data set, then we'll go for a break, and you are free to do the, you are trying to solve this during the break, right? And even after the, okay, so fine, we'll do that. So we'll quickly try to create the data set. Okay, so let's try to do that. All right, so let me say before, this is the before weight, right? That's dot norm dot RVS scale equal to 10 equal to 50. I'm taking the weight, so I'll try to go right closer to 50. Maybe 50 is the average, what I think, right? You can change this. Now you see the sizes will be same because before I measure the weight of 100 patients, okay, and after also I'm doing the same thing. Okay, so after is equal to, you see something, some change will happen with respect to what is already existing, right? So you see the change in the you see the method I used to change my data set after the experiment. This is before plus stats dot norm dot res. Now you see the change in the weight is having a standard deviation of 5, scale equal to 5. Okay, right? You see what I'm saying is that the change in the weight will vary plus 5 or minus 5. That's what is the thing. Somebody might increase their weight, somebody might decrease the weight during this whole period of observation. Right, that's the one thing. Again, location, most of them have reduced. So that is minus 3, maybe 3.5, let's say. Right, most of them have reduced their weights with the average value of 3.5. So minus 3.5 is what I assume. Okay, and what is the size? Should be same, right? I'm repeating for the same 100 patients. Okay, so this is my data set. All right, so I have created the data set. It is left for you to perform the test now and give me an answer when we come back from the break. Okay, so the before joining the program, the weight is available right in the variable called before, and uh, after the program, right, there is a change in the weights. Again, it is normally distributed, and you can see that it is present in the after variable, right? So I can see one answer saying that okay, from Devendra, average weight is 50, and before it is 52. So it says that there is a decrement in the weight, right? So this is what is there. Okay, I have a better idea to visualize that, right? So let's see, right? Okay, maybe so this answer will definitely vary from your system to my system. Okay, because if the random numbers generated are different, this will change. Okay, but yes, so there is before you have a larger weight, and after that you have a lesser weight, right? So that's what is expected, because as you can see here, the value is reduced, right? So minus 3.5, average value is that. Okay, so what I do, I'll create a data frame, right? So df is equal to pd dot pd dot data frame, right? I create a data frame, right? The first thing is before, and put the same variable before over there. Okay, then I have the after. This is the column name, and I'll put after over there. And I also want to check what is the weight change. All right, so to find the weight change, this is the change column. And how do you what do you want to put over there? It is maybe, right? I'll put the final value, that is after, minus before. Okay, so this is what I want to create. Let's say that I have with me, and df dot, let me look at a few of the entries over there. So this is how it looks like. So before 63, after 54, there is a change like this, 46, 34, like this, and so on. So right, there is a decrement, right? Age has been reduced for most of the cases. There, here and there you will find some of the cases where weight might have increased. Okay, so that's the first thing. And in order to find out this average of before after, you can use the describe, right? So df dot, right? So describe function, right? Simply click over there, you will get the complete image, right? So count for how many values you have. We have 100 counts, and you can also see that mean of this before is 50, after is 46. Yes, as I told, it's a different for different systems, right? Because the number of sorry, the random number generated will be different. Okay, and minimum value, maximum value, right, etc. You can see the complete right picture of the data which we have created. Okay. Anyway, this has nothing to do with our question, right? So directly let's move on to the question now, right? So I'm going to call this. Okay. So this I'll ask a question first. So let me see, right, whether you are able to give an answer or not. So my question is that uh, if you conduct the paired Z test, what is your conclusion? Saying that, right? Is there this what you call this particular maybe the weight change program for which the patients got admitted to has a significant effect, right? Will there be a significant difference or no? Is my question, right? So I want you to try that, right? So write a function which is similar to this, or sorry, this one. Okay, very similar to this. I want you to write a code, right? Get the P and Z score and give an answer, right? This is what I want you to do, right? Anyway, the data is available with us, right? You see before and after, only these two you are using. Okay, you will not use anything I wrote after that. Just for understanding purpose, I wrote this part of the code. Creating a data frame and describing a data frame has nothing to do with this. So my data is still before and after. I want you to use that data before and after to write 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 a code and tell me, right, is it useful that people joined that program and they got benefited or not, is my question. Okay, so is there a real effect, right? Something like right the joining that program is really helpful, or there is no effect, is my question. Okay, so try to write that code, right? I'll go back and I'll show you that code which yeah. So something like this I expect you to write. Okay, look at the details of this function. If at all you want to modify, you look at that. Okay, so go to the details, put a question mark over there, find it out what are the changes you are supposed to do, if at all you have to. Okay, find that out, do it and get back to me, right? So you have 2 minutes of time to do this job. Okay, meanwhile we are open for questions. Anybody has a question, please feel free to ask. Sorry, can you repeat the error? Okay, end of line. So you have missed the comma or bracket close or something. Okay, just check that, right? EOL stand for end of line. So line should be ended properly. If you have opened the bracket, that should be closed. If you have opened a flower bracket, it is expected to be closed. Okay, right? So just check these comma, right? And if everything is fine, then there should not be any error. So just check whether you have imported the pandas as well. Okay. Other than that, I don't expect any errors should be coming up, because only these are the two things. Import the pandas and also just look at this. Okay. Yes. Yes, Mona. Yes, please go ahead. Okay, sure. So see, there's a program which conducts a training for reduction of weight. Let us say, okay, group of people, say 100 people, are going to join the program. Before joining, you measure their weights that is present in the before. Okay, and once they finish the program, they come back. You measure the weights that are present in the after. Okay, so now the question is, right, whether that particular program is helpful in reducing the weights or not. Okay, so you will make H naught saying that they are same. It's something like there is no effect in the sense before and after same weight. Maybe you will do like that. And H alpha will be right. No, there is change in weights after the program. So you have to tell whether H naught is correct or H alpha is correct. So you will perform what is called as a paired Z test, very similar to the one which we did earlier. That is a question. So once you get a Z value, you get a P value, right? And P will be compared with alpha equal to 0.05 only. Okay, I want 95% confidence level, which means alpha value will be 0.05. Compare the P value with 0.05 and then you give your answer. Okay, this is what I'm expecting. Okay, anybody? Take 30 seconds more and try to give me the answer. Okay, we have one answer coming up. Z score equal to 3.02, P equal to 0.002, right? Okay, let's see. This answer is depending on what are the numbers that have been created in your system. All right, so fine. Okay. Let's see what I'm going to get. Okay, just compare this particular table. If you have the values very similar to this, I'm also expected to get the same answer. Okay, so just see what values you have here. When you get your table like this, right? When you describe your data frame created, if you're getting a very closer answer, closer numbers, what I am getting here, then it is expected to get a same answer. Okay, if you have a different values here, right, then it may be a different. Okay, so like that we can verify. Okay, all right, let's check. Okay, I don't have answer. I will write a code and will. Okay, sure. Okay, others, anybody who has written a code? It's very similar code. You don't have to change anything, I guess, right? Everything will remain pretty much same. Okay, so let's do the test. I'm going to call it as a pair test. Okay, pair test is equal to sm dot stats dot z test only. You are still doing the z test. Okay, x1 should be the before. All right, and we have x2, right, and that is equal to the after. Okay, so we have before, we have after, and right, we'll write the, yes, correct, value equal to 0 because, right, my null hypothesis says that there is no difference, right? There, in the sense, uh, uh, before people joined, they had a weight. After finishing the program, also same weight. In the sense, the program is of no use for. This is what is my null hypothesis. Okay, and what will be the alternative hypothesis? This says that, right, there is change, right? There is difference. In the sense, weight may increase or weight may decrease also. Correct? So it should be two-sided. Two-sided. Okay. So let's run that part. So we get this. Now I'll print the z value. So what should be the z value? It's the paired test of 0. I'll also print the p value. Pair test of 1. Right? So you can see, yes, whatever Gaurav got, I'm also getting the same thing. Okay, hope you all, everybody is getting the similar answer. Right. So what's your conclusion? Give me an answer about, right? What is your conclusion about this? Yes, Somesh. Say this. Okay. So you see, whenever we are comparing two different, right, samples, right, when we are doing the two different samples, right, there is a possibility that my average may be more than or less than. Both are possible. Correct? More than means one side, less than is another side. So clubbing both of them two sides. That's all. Okay. No, no, this has nothing to do with the null hypothesis or something, right? You see, pair test is a variable, right? This is an array. Okay. This function, when you run this function, answers come inside this. Okay. In that, the first value will be the z value, next value will be the p value. I'm simply printing that. That's all. Okay. Yes, 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 correct. So, what is your conclusion? The conclusion will be like this. I'll try to write it quickly. So, the p value is lesser than my alpha value. So, that I have taken as 0.05, which is a very standard value. Okay, right. So, since that is the case, right, p value is less than the 0.05. That means reject null. Okay, reject h naught. I'll just write h naught, right? So you reject H naught. In the sense, H naught, my statement for H naught was that treatment or that particular exercise is of no use because weight did not change. That's what I said. But actually, right, weight changed, right? How do you know that? You see the change, average value of change. For 100 people, when you take an average change, it is -4. In the sense, weight has been reduced, right, by 4 kgs in an average. That means that's one reason why I actually had a description of the data frame over here. right? At least just to justify that, yes, whatever answer you're getting here, right? It has some sense. Okay, it's not doing at random. It's not something like that. You see that weight of, right, out of 100 patients, few of them there may be increased, but you see, right, there is a reduction of weight by 4 kgs, right? That is the average change. So when such a change happens, you cannot say that there is no difference, right? Average of 100 people is reduction of weight means yes, there is, right, some effect, right? So because of which the weights have been have been reduced, and you can say that yes, that exercise is useful. Okay, right. Okay, so moving on to the next part, I'm going to share one particular file now, right? I want everyone to use the same thing. Okay, so just give me a second, I'll share that. So that is one file. Okay, so the file is actually added to the chat, right? Everybody, I expect those whoever is running the code along with me, right? I want you to download this. That's what we are entering into the second half, right? Where I told we'll work on a real data set. So this is the real data set which I am talking. Okay, right. So this is actually a professional salary survey data set, right? In 2019, and it actually contains few other years also, but I named it as 2019 because I'm using for a particular year 2019. Right? It's a salary survey, right, of various companies, various fields, right? Male, female, etc. Right. So this actually has the uh, parameters such as which year this was conducted, and it's in US. Okay, so the salary is written in the form of US dollars. So what, which year conducted, what's the salary, and it also have the country, again mainly US and other countries also, surrounding countries we have, right? So we will stick to one of the countries only. Then uh, education, what's the education background of an employee, which sector employee belongs to, which sector, and gender, mainly these are the various things we have. Okay, so what I do, anyway, so you have the document with you, you have the data set as well with you. So paste the data set in the same folder where you are running your Jupyter. Okay, otherwise it will throw up an error at a later stage. Okay, so let's quickly load the data. All right, so I'll call it as my raw data, because you see this is a real data, you have to pre-process, everything is not ready, right? So we'll see how to do that. Okay, so raw data is equal to pd dot this data set is in the Excel form. Okay, so I have to use read underscore Excel. Okay, I have to say, okay, just open that and see, if you can, you open that separately and see, right? What you notice, you have to tell me if, right. You may have to check again, Ruchi, because it has been added, it has been shared. Okay. Others, have you received or received, right? Okay, okay. Yeah, yeah. Yes, others have received. So, Ruchi, please check. Okay, you may have to wait, or I don't know, because it has been shared, others are getting it. So, I don't have any other control over here. It's just shared and it should be coming. Okay, fine. So, read Excel. I'll just type the name here. Okay, so that is single quote 2019 underscore data professional underscore salary underscore survey underscore responses dot xlsx. Okay, so this is my file, and when you open and see, right, you will see that the header is actually located in a position equal to 3. From the top it's third position, so I have to tell, otherwise it will read the blank locations also. Okay, so header is equal to 3, right? This depends on what data set you are handling. You should have an idea. Yeah, that's a better idea. Those who have received, kindly put it into your group. All right. If you have a WhatsApp group, kindly share it over there so that those who have not received can get it. Okay. Yeah, that's a good idea. And now I'll see my data. Okay. Uh, raw data. Sorry. Raw data dot head. So I will see the first 5 data from there. Okay. So you can see this is my data, right? So only first 5 will be shown by the head. If you want more, you can enter here head of 10. If you enter say 10 here, you'll get 10 values. Okay, so you'll get 10 rows. So you see here, this is 10. All right, so I don't want 10. I want to keep it default. Default is 5. If you don't enter anything, only 5 will be shown. Okay. All right. So this is the data as I mentioned, right? So you can see, right, the salary in USD, country. You can see various countries also do exist here. Postal code, etc. Many things you have. Okay, this is the data set. So far I have not asked a question, right? So I will ask you the question, right? Once everybody is ready till here. Okay. So just make sure that you are fine with this. Okay, you are okay with this, and I'll frame the question now. Sorry. Yeah. Sorry. It's a complete name of the document. Okay. Yeah. Please see here. Sure. Right. I'm writing the question here. Those who right want to make an attempt, please try to answer this question. Right. I'll be coming slowly with others. Those who are ready till here, those who want to go ahead, please go ahead. After looking at this question. Yes, Gaurav. Okay. You may have to load it right to the collab locations or something like that. There is a procedure, right? Okay, you have to load it to because you are allocated a computer on Google's location, Google server. So this file needs to be loaded to that location. Only then you will be able to. Okay. So there is a procedure. Just Google it out. How to upload a data to the Google app. You will get a procedure. Just follow that. It will be done. Yeah, that's what I said, right? So you have to go to that, you have to select and you have to upload, right? Sure. Okay, so this is the question, right? At alpha equal to 0.05 test whether the salary means, okay, alpha equal to test whether the salary means of male and female employees in the year, okay, in year 2019 belonging to United States are equal, right? So the data set is actually huge. It contains many more things than required, but you have to make sure that you only access those values which are asked. Like I want to go for the salary. I want to compare only something related to the salary. That's the first thing. Male, female is the bifurcation, and specific year 2019, because you see that survey years start from 2007. I have to go to specific one, 2019, specific country, 2000, United States, because you see the data contains other countries like UK, Germany, France, etc. Right? So first you do a pre-processing, and then you will be able to come to a point where you can do the text. Okay, so something like a more practical approach. Right? These kind of problems are what you normally get under the data science. Right? Okay, those who want to go ahead, yes, please go ahead. Right? So my next approach will be, right, I will see, right, how many data sets I have, because I should get an idea saying that okay, how many data points I do. Okay, so uh, uh, sorry, raw data, right, shape. So you see there are 29 columns and 6,893 rows, right? So it's that huge data, right? Now I have to deal with the, right, what is called as a not a number values. Okay, because we will be having bad issues most of the time, right? I have to check that, right? How many uh, how many of the columns will have not a number as an entry, right? How do you check that? Anybody? So this is a pre-processing step. Already in the EDA, we have seen this, right? So you should be able to recall. This is what I expect, right? At least the command which we are supposed to use. Okay. Anybody? Okay. Uh, Other than the user-defined function, do you have any built-in function? I'm looking for a built-in function because it is pretty straightforward. Okay. Anybody, are you able to recall that? In the raw data, I'm supposed to check, right, is NA, right? I will call for some. Let's check this, right? Is NA means yes or no. Whether there is a not a number or not, I'm asking, it will say yes or no. If you have a yes, take the sum. That's what is my comment here. It says in postal code, you have 959 entries, right? Which are not a number, maybe blank. That's also, it's a not a number. Other database, 1373. Education is computer related or not. Somebody did not enter, that's all. Okay, right? Like that. So many things are there. Okay, so we have not a numbers, right? I have to deal with them first, because before going ahead, right, before proceeding further, it is always required that you make all of them. There should not be any not a numbers, right? So what do you do? Raw data, drop NA is a inbuilt function once again. I'm simply saying that, right? When you, it we say that wherever you have it, that not a number, drop that complete row. This is what I'm saying, right? So drop NA, I have to say that in place, in the at the same location, bring the next one to that position. So it is in place, equal to sorry. Yes, Ruchi. Yeah. Perfect, perfect. You can. No, I'm dropping. I'm following the standard procedure so that everybody is able to recall, because this is going to come at a later stage on a huge margin, right? There, people should not struggle. Why I'm doing this? What I'm doing? I'm trying to make people to recall every step by step procedure of a EDA. That's all. Okay. So yes. It's not required, right? You can, as I told, right? Those who are ready to go with the at their own pace, you can go ahead. No problem. Okay. Later on, we'll compare our. Yes, sure. So I'm trying to drop that, right, as a standard procedure, and I have to reset my index, because index will be 1, 2, 3. Fourth one was not a number. I eliminated. Fifth one will come to the fourth position. So the index should be changed to 4, right? So that is what also I have to do. Okay. So raw data dot reset. I think there is a reset index. Okay. Right. Wherever you have drop equal to true, and in, yeah, in place equal to, okay. And now I'll check raw data is an a dot sum. What I'm expecting all zeros. Yes, Somesh. No, what's the question? I'm not able to get. Can you kindly repeat? Ha. No. Simply load this. That's all. Right? I'm reading that Excel sheet and I'm using that in my code. That's all. Okay. Simply load it right like this. So you see, pd dot read Excel means I'm reading that Excel. Yes. Okay. All right. Fine. Sure. No problem. Okay. Then, all right. So let's see what else we have. Okay. Directly, I'll jump into the what you call maybe the salary, right? So because anyway, unwanted numbers have been rows have been removed, right? I'll directly jump into that. Okay. So there is a raw data of, let's look at a column which gives you the salary. What's the name of that? Okay, it's a salary USD. Okay, so this is the one which I'm looking for now. So I'll specify that salary USD. I'll check out what are the unique entries over there. Let's find out that. Okay, so that is unique, not coming. And yeah, unique. Right, what are the various numbers you have as a salary? You can check. Okay, so these are the various salaries present over here. Do you find something which is okay? There is, so everything looks like a number for me, but there is one thing which is not a it's not a whole number. In the sense, there are different types of data. I need to convert everything into the same. This is what is my point. Okay, looking into the data is also important, right? That's what is my point, right? Don't uh, if I plot so many numbers, right? Most of the time people think that okay, everything is same, let's proceed. But you need to be very careful. You see, there is a dot to point two there, right? Anything else you observe here? You see here? So there is something like, right? Single code is being used, which means I need to remove that. Okay, please look carefully and observe something. If you observe something which I miss, please tell me. Okay, and there is a single quote. Do you see anything else? There is this number, there is a dot point 2, and again, two decimal places. Okay, everything looks like an object form. Okay, data type is an object. Okay, do you see anything else? Only that much, or do you have? No, no. Somewhere I saw a dollar symbol. Can anybody identify a dollar symbol there? I previously I observed that as well. So now I am not able to trace it. Please find out whether there is a dollar symbol, because it's in dollars, right? Somebody has entered a dollar over there in the middle. I have to eliminate that as well. Okay, so I saw earlier, but now I am not able to trace it. Looks everything looks pretty much in the same format, right? Also, I had observed a space somewhere in the middle. Okay, two things I'm searching right now. No, I don't see. Okay, maybe remember where I saw that. Okay, all right. Let's proceed. We'll proceed with the coding. We'll not waste time. Okay, so let's write a function that actually processes this. Okay. Yes, Mo. You have to put it into the same folder where you are running the Jupyter file. Okay, this Jupyter file you are running in some location, right? It's I think it is different from desktop, right? So copy from the desktop, you copy to the same location where you have saved this file, the Jupyter file, right? My Jupyter is by this name, in class this number. This is my name. This is not in desktop. This is in a different location. Okay, same location you have to paste that particular file. Then it will directly run. Otherwise, it will throw an error. Same location where this file is. Okay, this file may be present in C drive, some folder, or right somewhere, right? This file, right? Wherever you are running the Jupyter, that Jupyter is located not on the desktop. It will be somewhere else, right? Some other folder, document, right? So that means you have to paste that file, the Excel file also to the document. You see where it is. Okay, same location you paste it will run. Okay, so let's proceed further. Now I will define a a function. Let's see. Process the salary, and I'll pass a value to this called salary. Okay. Then what I do, I see that there most of them, few of them have the something like cents present over there. $200, 0.55 cents, something like that. So I'll define a separator. Okay. Sorry. So the separator I want to define now is equal to uh, this one. Okay. Salary. Okay. I'll show you something else. Okay. So that is, let me look at the type. Okay, type is here. It's already shown that this is of object type. Otherwise, you have another method to check that. Okay, so that is raw data of the salary column, salary USD, right? That itself I want to check as dot e. That will also show you that, you see, this is a object type. So we will not be able to process something which is in the object type, right? You need to convert that. So the most preferred way to convert, right, will be the string format. Okay, because the dot actually is a string. I have to remove the string somehow. All right, so salary is equal to perform the typecasting str of salary. So I'm trying to extract from there. Then I'll process salary is equal to salary dot replace. What you want to replace, right? I'll see. Right now we are not able to see that there is a space here, right? Okay. This itself is a space. Sorry, please observe. There is a space here. If at all you find a space somewhere, you have to remove that. Okay, so replace, right? What is a space? This is a space. Replace the space by this. You see, there is no space between the uh, two single quotes. I don't have a space, but first thing, there is a space. So there is a space here. I'm removing the space by using this. Okay, after doing that, dot replace, right? What else you want to replace, right? If at all you have a comma, that also you replace. Okay, uh, this is a comma. Replace it with like this. Okay, then let's let us check for one more time whether we get a dollar, because I saw the dollar. I'm very sure somewhere I saw a dollar symbol. Even if, okay, let's say let's not waste time finding out that. So I'll write a code for that. If it is there, it will use it. Otherwise, it will not use that. Okay, so dot replace, right? I'll just write a dollar symbol. Okay, so dollar. If you have a dollar, right, replace it with the no. Okay, okay. So then you split. Okay, split on what you have to split. Wherever I find a dot, I need to split. Okay, so use the separator. Okay, and go to the first part of that. That is 0. In the sense, if I have 25,000.35, 25,000 is the first split. After the dot, I have a 25. That's the second split. Consider this number, the bigger number. That's what I'm saying, right? Because that dot sense I am trying to neglect as of now. Okay, right? So just see here. So this is what is happening with this. All right. Then okay, so this is what happens initially. Then okay, let me check what else we can do. Okay, I have this number. I want this. It's a string now. It's no more a number, right? I have to convert that into floating value. Then I return. Okay. After doing all these steps, I return the float value of the final answer. Okay, so this is what is my problem. Let's see whether this runs. Okay, as of now, no problem, right? We'll run that part and we'll check that. Okay. All right. Then raw data salary USD. Right? I'm going to call the function now. Okay, so that is equal to raw data salary USD dot apply. Okay, you are applying a function for the whole column. What function you are applying? You are applying the process salary. Okay, after processing whatever I'm going to get, I'll try to print out that over here. Okay, this is raw data salary USD. Right, you see everything is kind of okay, or else I can just give dot head. That should be right? Oh, sorry. Dot head should be having this. Okay, so first five values I can see. Everything is converted into float, right? That's what is ultimately required. Okay, right. Now I have to look at the year, right? So uh, wherever I had to process the data corresponding to the salary, I did that. Now I have to extract only 2019. So where is it located? It is located in the year, right? So that is survey year. So I have to go to that column and I have to extract only those numbers which contain 2019. Okay, so I'll what was the name of, it's a raw data so far. Now I'll come to the data frame. So df is equal to, I'll create a new data. That's all. Okay, df is equal to, from the raw data of, right, I have to look at a survey year, right? So raw data of survey year. Oh, sorry, I have to do one more. Raw data of raw data of the survey year. Okay, equal to 2019. Okay, that is the df. Wherever I find 2019 in the survey year, only those rows will be picked up and that will be put into, right, this df. Right? So df dot head. So just see 2019, 2019, 2019. That's all. All right. Once again, right, what I do, I will, this is 2019, but you see the years, the countries are different. I have to go to a specific country, right? So I'll just write US 2019. That is equal to, in the previous available data, that is most recently updated data is df. So in the df, right, I'm supposed to look for something. Df dot location, right? I'm using a different kind of coding. That's all, right? You can do the whatever we have done earlier. Df of, right, df of country equal to US. You can do that. Otherwise, I'm trying to do it in a different way. Df dot loc. It's a location, right? Go to that location where the df dot, what's the name of the country? Yeah, it's a country itself. I just have to use this. Go to that country and find out wherever you have United States. Okay, so df location of df of country equal to, right, it is United States. Okay, so all those rows, right, I have to bring it, comma, it's not just that, column should be kept as it. That's why column, all the columns. Right. Whichever rows you have United States, go to those, keep those rows and all the columns. Eliminate all the other rows where you have other countries. Okay, so this is what is the meaning of this. There is another other approaches also. You can write the same line of code in your own way by using a different approach. Okay, that's also valid. I'm just trying to show different one. I don't want to keep the same code like this. I just want you to explore more. So that's why I'm trying to do this. Okay, so here also I'll try to do US 2019 dot head. So I just want to now what you should see, you should see only the United States here. Others should be eliminated. Okay, fine. So we have the smaller, what you call the smaller version of the original data table with us. We have come to the very close to getting our answers, right? So now in this US 2019, let me check out where is that gender column, right? So do you have something? What's the name of the column? I'm looking for that column. Yeah, it's called as gender only. Okay. So let me try to find out the counts. How many male, how many female, right? So that is US 2019. Anybody? What is the command using which I can check how many number of males? What's the count of male employees and what's the count of female employees? Yes. You have 1 minute of time to think and answer, right? So tell me what do you type here so that I will get as an answer. Male, these many candidates, these many, right? Employees, female, these many employees. Something I should do. Dot. Okay, let's check. Unique, this is what you see. Huh. Okay. Sure, sure, sure. Square bracket. Okay. Single quotes, gender. All right. After that, you are saying dot unique, is it? Right? It says there are two entries over there, male and female. That's right. That's okay. But I want the count as. This is the first step. Can you modify this so that I'll get male, say 250, female 150, something like that. I need that. Right? It's halfway. Whatever you told is halfway. Correct. Yes, go. Please go ahead. Dot count. Do you have a dot count over there? Let's check. No, there is no. You can see that there is no command for count. Something else. Dot sum. Will it support? Let's see. It's male female, not that. Value. Let's check. It is not suggesting anything for. Let me check val. No, once it is unique, I don't think it will give any value for it. So before unique also something has to be done. Let's check the val here. Okay, let me check. Will it give a val here? Yeah, value count comes here. Just see. Yeah. Okay, let's check that. Value counts. Sorry. Oh, it's a total number. Sorry. Let's see. Will it give this? Yes. Okay. This is the way, right? Anyway, there is no meaning. I'm not expecting everyone to remember something, but you should try. Okay. So yes, I appreciate everyone who participated in that part. Okay. So let's go ahead. I understand that there are 274 male employees falling under this category who are from US, who is in 2019, etc. Right? Every condition who satisfies that those set of conditions, 274 male, 26 female. All right. Okay. Now what I want to separate male salary and female salary, isn't it? Because I want to make a comparison out of it ultimately. Correct. So male salary should be equal to, this is from this particular data frame, US 2019. Okay, so what I am supposed to look, male and salary. So how do you check out whether it is male or not? It's the same thing. US 2019. See, there is a dot operator. If you remember, you can use it pretty easily. So okay, I'll show something here. So you, anyway, what you did is right. So US 2019 square bracket gender dot value count, that is pretty much valid. But I'll suggest you to do this. US 2019, right? Simply type dot, right? Don't go for a square bracket listing. That can be avoided by simply using a dot notation. Dot gender. Then you go for dot, then whatever you want to. That's a value counts. right? Just check that. See, both will work. So my intention is to save some time and make it easy for you. That's all. So same thing I'm going to do here. In the US 2019, in gender column, okay, I want to compare and get those who are male. Okay, get them, and in that I am supposed to get only something which is called as salary. What's that? Salary USD should be there, right? So it's not saying salary USD. It is there, right? Let me just check once whether we missed that. Dot is missing. Yeah, salary SALARY USD. Okay, where you are saying dot is missing here? No, I don't need a salary. I don't need a dot over there. Okay, this location no dot required. Okay, let's just run that. Yeah, it's running, so no issue. All right. So similarly, female salary is equal to same thing. US 2019 of US 2019 dot gender equal to, now I am supposed to look for female, right? I get, right? This means some of the rows will satisfy this condition. In that, right, look for the salary USD. Okay, so that becomes the female salary. Now you see, now I'll see that. Okay, male salary dot mean, right? So female salary dot mean, right? You see that, right? These are the answers. Now what I'm supposed to do, right? I have to go for the test. Now this kind of what you call test actually falls under, right, what is called as the last category which we are supposed to look, that is called as a t-test. Okay, so I will show you how to perform the t-test. So far what we did is, right, collecting the data set, processing the data set so that you keep only the specific data which you want. Right. So I had a huge data set. I actually, right, performed the simplification. I performed the processing. I eliminated unwanted data set from them. And now I have only those columns which are required for me, satisfying a set of conditions. Okay. So any doubt so far? Right. This is the EDA step. That's all. Right. I'm trying to analyze the data set and I'm trying to cut short my bigger table into a smaller table containing only those things which I'm interested in. All right. Do we have any doubts? Okay. So that means that's fine. So now I will show you STATS stats dot t-test t-test. Which one? I'm going to use INT. All right. So let's give it question mark just to see what we are supposed to use. So, right, it's IND stands for two independent. T-test of independent. See, male, female, it's independent. Right? So that's why it's independent. There are other versions also. You can check, right, later. So these are the parameters to be passed. A, B, axis, right, right. Many things are there. So now we'll look at what we are actually interested in. Okay, so the first one which we'll be passing is A and B. Both will be the arrays, right? So both whatever you pass, right, is expected to be of the same shape except in the dimension corresponding to the axis. In the sense, one axis you can have different numbers. So you see the male has 274, female has 26. That doesn't matter. Okay, axis int or none are optional. Axis along which the compute the test, if none over the whole arrays. Normally we will not pass anything to that. We'll keep it default. Okay, as of now we are not passing anything. Okay, then yeah, we will be using this variable called equal weight. It's a boolean, right? Whenever you enter true for here, it performs the standard independent two sample test. Okay, right? It means assumes equal population variance, right? But if you put it false, it is performing the t-test, right? Assuming not. So what I expect here now, I'm going for a t-test, so I will put that as a false. Okay, so then anyway, we have many other things available here. As of now, we are not going to use, right? So if required, you can explore and you can use it further. So let me see whether they have given any example how to use it or something. Yeah, you can see that even as I told earlier, sometimes you get examples as well. Okay, so how to do the test, etc. Examples also available. Here you get an example. Yes, Ruchi. Yes, Ruchi. Yeah, any test is possible. You can do, but this particular data set, what we have, right? Same example I had given when we discussed about the concept in the theory part, right? So there you get a clear cut explanation saying that why we go for this. Okay, but you can do other tests also if required. Okay, so we'll go for the testing part directly. All right, so I'll define that as say t-test is equal to stats dot t-test underscore ind, right? Pass the various parameters for this. First one is A. A is equal to, maybe you'll pass female salary. B is equal to, there is no order in which you are supposed to pass. Male first, female next, doesn't matter. Okay, comma, EQU, there is a equal variable that is equal to, it's a boolean. Just now we saw that if you want to perform the t-test, this has to be false. Okay, so right, so I can go for, yeah, there is another way to check this, right? T-test, simply write the t-test. It will show both of them. You see, result, t statistic, t value is equal to this, p value is equal to this, which we didn't do earlier. Earlier we used to type everything, right? That's not necessary. If you know where, what index corresponds to which value, right? First one is a statistic, then you have a p value coming into it. If you know that directly, you simply enter this, right? So that you will get that statistic equal to this, right? This is an alternative approach. Okay, so anybody who can conclude from this what you can conclude, right? Please go ahead. Correct. P value is equal to 0.02, right? And our alpha is equal to, as already mentioned, 0.05. So I observe that the p value is lesser than alpha, right? So that implies reject the null hypothesis H naught, right? So what do you mean by that? So initially null hypothesis should be there is no difference between the salaries of male and female, right? So that is what the null hypothesis. But right after doing this, we understand that we could see that, right? It's always. Yes, always. You see, look at the previous examples. Previous examples also same thing. The average, that is a difference. That is a difference. Difference between equal, right? Right. So that's actually two sample test. Correct. That's a different test. So you have to go back and check what are the various types of tests possible. According to the test, we have to make the changes in the program. That's all. Okay. So So here, right, always in every case, the H naught will be saying that there is no difference. Both are same, like that. Okay. So H naught will be the same thing. H alpha will change, right? Saying that something greater, something less, something not equal to, right? Like that. Right. So in this case, right, the first statement H naught saying that there is no difference between the salaries of male and female. Right. Always the H naught will be defined in such a way that you say that there is no difference. Right. Everything is same. Then H alpha will be defined in such a way that, right, you should be able to differentiate. Like, okay, it is not equal in the sense you will perform a two-sided test. It is less than means you will do a left side test, right? It is greater than means you will do a right side test, like that. Okay, so try to recall. It's everything is there in the notes which I already have provided. It's also there in the sorry, the PPT. Okay, kindly go through them. Everything will be clear. Then you come back to this particular document and it will be more clear. Okay, so as of now, H naught is saying that male female salaries are not different, they are same. But this test result says that, right, you have to reject that, which means there is a difference between the male and the female salaries in US, right, in the year 2019. Okay, so this is what is your conclusion. I hope that is clear. Okay, do we have any other doubt? So four major tests uh, are there, right, which we had discussed in the theory part. Now I have given the coding view of the same thing, how to perform the coding. First, a few examples were the randomly generated data. Then later on, we consider the actual data and we have performed this. Very similar to this, I am expecting you to, right, explore this further, take any other data set which is readily available, make your own question and try to answer that, okay, by doing any of the tests, right, which will give you a lot of experience saying that, okay, what data set, which particular test I'm supposed to do, etc. You will be, a lot of things are there to learn, okay. So I expect you all to go ahead and do that. So that brings us to the end of the module called the statistics, specifically in inferential statistics. Okay, so in the upcoming session, we'll be moving ahead to the next topic, that is actually the probability, right? It's a simple, a very small topic. We'll try to cover that up as quickly as possible so that we can go ahead. All right. So with that, we'll come to the end of the today's session. Right. I hope this session is useful to you, and I appreciate your efforts, your patience in during this class. Okay. So have a good time. Good day. We'll meet in the next class.